So this one, we're going to talk about products and quotients of complex numbers in polar form. So we've been kind of converting complex numbers to this trigonometric form, and we said that it's going to make certain computations much easier to work with. So we're going to look at products and quotients because basically that's kind of the hardest thing to do. So let's say you have two different complex numbers, z1, and it's already in its own trigonometric form. Okay, theta 1 and theta 2 are just their respective angles. And basically what it says is that if you want to multiply two numbers together or two complex numbers together, remember that the way that we did that was by foiling everything out. But what it says here is that if you know that they're in complex form already, all you got to do is multiply the r's together and then take the cosine of the sum of the theta values and the sine of the theta values. So that's much easier than foiling a whole bunch of stuff together. And also, if I wanted to divide two of them, and we saw that that can be a little difficult as well, all we had to do was divide the r values and then subtract the theta values. Okay, here is on the condition that z2 is not 0. Okay, because if it's 0, then it's undefined. So I'm not going to derive them. They're basically pretty basic to kind of derive. All you got to do is just use the sum and difference formulas. So basically, you're going to start out by taking this guy and this guy, foiling everything out. Things are going to cancel out, and then you're going to have the sum and difference at the end. So you can have that as an exercise for you to look at. We're not going to go ahead and derive them here. Okay. So let's go ahead and just do a couple of examples here. So suppose that z1 equals negative 1 plus square root of 3i, and z2 is equal to square root of 3 plus I. So we want to find z1 and times z2. So clearly what we can do is we can FOIL all this out. Well, let's use the formula that we just learned. So the first thing that I kind of want to do is let's convert this to polar form. So let's first start off with z1. So let's figure out what its r value is. So let me call it r1. So this is going to be negative 1 squared plus square root of 3 squared. Okay, so this is going to give me the square root of 1 plus 3, which is the square root of 4, which is just 2. So r1 equals 2. And then theta is going to be the inverse tangent of y over x, which is square root of 3 over negative 1. Okay, so we've kind of already did this problem already. We said that this was negative 60 degrees. Now, remember that we said that this is not in the correct form, so we're going to add 180. So in this case, it's 120 degrees. So this is going to be theta 1. So basically, the polar form of z1 is going to be 2, and then let's write it as cosine of 120 degrees plus the I sine of 120 degrees. Okay, so that's basically the polar form of z1. Now let's find the polar form of z2. So the polar form of z2 is going to be r2. So let's take the square root of the square root of 3 squared plus 1 squared. Notice that the r value is going to be the same. It's just going to be 2. Here we want to find theta 2. That's going to be the inverse tangent of y over x, which in this case is going to be 1 over square root of 3. So now this is a little bit different because we're not looking at square root of 3 over 1. Okay, so we're going to look at the inverse tangent of 1 over square root of 3. And that's just going to give me 30 degrees. Okay. So, and notice that it is in the correct quadrant because this guy is in quadrant 1. So I'm not going to graph them, but just keep that in mind. So here z2 is going to be equal to 2, and then the cosine of 30 degrees plus I sine of 30 degrees. Okay, so now we've found them in polar form. Now what we want to be able to do is multiply them together. So I'm multiplying z1 times z2. So that remember that all that basically does is just multiply the r's together. So we're going to multiply this r and this r. That's going to give me 4. And then we're going to take the cosine of the addition of the two angles. So 120 plus 130 is going to give me 150. Plus I sine of also 150. Okay, so that basically is my answer. So if I were to FOIL these two guys together, then basically this is what I'm gonna get. So if you really wanted to go back to complex numbers, all you gotta do is just plug that in the calculator or look at the unit circle. So what is gonna be the cosine of 150 degrees? Well, that's just gonna be negative square root of 3 over 2. Okay, plus I, and then you're just gonna take the sine of 150, that's gonna be 1/2. Okay, so basically, when I FOIL this out, this is going to give me what? Negative 2 square root of 3 plus 2i. So if you really wanted to know what exactly it was in complex form, this is what it's going to be. So you basically just put this in your calculator, or you just go ahead and look at the unit circle and just FOIL it out. So we didn't need to FOIL it out. Okay, there's just an alternative way to kind of do it. So which is nice to kind of do it. Now, the only caveat is that we need to know what Z1 and Z2 are. Okay, now let's do Z1 over Z2. Now this is going to be a lot easier to work with because all we got to do is just divide Z1 and Z2 together, so or R1 and R2. So notice that here now we're going to take the division between those two. So R1 divided by R2, that's just going to give me 1. And then we're going to have the cosine of the subtraction of those two. So 120, so we're going to take 120, and then we're going to subtract it by 30. That's going to give me 90. Plus I sine of 90. Okay, so basically this is going to be the answer. Again, if you wanted to know what exactly this was, if I divide two of them, these two complex numbers together, without having to do the complex conjugate, instead I can just rewrite it as polar form. So here, the cosine of 90 degrees is just going to give me 0, and then plus 1. So basically, when I do that, I'm just going to get I. Okay? So a really nice way to kind of just do it. So this doesn't take a lot of time. They're very basic in that sense. But other than that, this is just basically what you do.